Hello, Matthews Gatos here. Welcome to part 2 of quadratic formula. In this video, we're going to look at the discriminant and nature of the roots. But before I do that, I just want to review with you a quadratic formula question. So this one here, we want to find the solution. So remember, anytime you want to solve any kind of an equation, you set it equal to 0. So I will subtract 6x and add 3 to both sides of the equation. So now that I've done that, I can see that this can't be factored. I could solve it by completing the square, but I'm going to solve it with the quadratic formula. So quadratic formula, look for the number in front of x squared, which is 1. And that goes in 2 places in the quadratic formula. Look for the number in front of x, which is -6, and that goes in 2 places. Remember, this is opposite b, so it's opposite the sign. And then C, my y-intercept or lonely number, goes there. So to do this, I'm going to evaluate what's underneath the square root without actually taking the square root, and that's 24. So I'm just going to, on the side here, because I know it's square root of 24, show how I'm going to break that down. So I look for a perfect square factor, which is 4. 24 is 4 times 6. So root 24 is root 4 times root 6, or 2 root 6. So I have 6 plus or minus the square root of 24 all over 2. So I know that root 24 simplifies to be 6 plus or minus 2 root 6 over 2. And then remember that we always want to put our roots in lowest terms, which we already did, but we also want to put our numbers in lowest terms as well. So I just draw a little heart around my numbers. So we love our numbers, but we want them to be in lowest terms. I notice all those numbers are even, so 2 is a common factor. So let's divide this one by 2, this one by 2, and this one by 2. So I know x is equal to 3 plus or minus 1 root 6 all over 1. Or you don't have to have all those ones there. You can just say the answer is 3 plus or minus root 6. So because there is a root, I'm okay leaving the answer like that. I just want you to know that there are 2 solutions, 3 plus root 6 or 3 minus root 6, but I'm okay with you leaving your answer like that. So we can always check on the graphing calculator, which I do recommend you do for every single one. I put the original equation into y1. I start my table at my first solution, 3 plus root 6, and you can see in the table it equals 0, which it should. I check my second solution, which is 3 minus root 6 in the calculator, and you can see it also equals 0. So I know both of those are the correct solution. Okay, so we can't talk about the quadratic formula without talking about the discriminant, which is that root. So that's what I always put in my calculator to evaluate without taking the root. So the discriminant is the radicand of the quadratic formula. Again, remember, it is what's underneath the root without actually taking the root. Now, this is so important because it tells us the nature of the roots. And when I say nature of the roots, I mean how many solutions they are, and what type of solution are they. So that discriminant under the root is really important because in math, we can never take the square root of a negative number in the real number system. So that discriminant tells us some important information. There are actually 3 cases for the discriminant. It can be positive, it can be negative, or 0. Each one gives us some information. So let's look at the case of where the discriminant is positive. That's when you're going to do plus or minus the root of something. So since you're doing plus or minus, you're adding and subtracting, you're creating 2 different solutions. That's like what we just did in the last question where we had to add or subtract the roots. Now, if the discriminant was equal to 0, imagine I had a number and I add 0 and subtract 0. It's kind of like going in a circle, spinning my tires. I'm not going anywhere. If I add 0 or subtract 0, that's really just the same number. So when the discriminant equals to 0, there is 1 real root. Now remember, these are perfect square trinomials. This is where I just have one x-intercept. And then the second case is where the discriminant is negative less than 0. And remember, in that case, we can't square root a negative number in the real number system. So we would say there are no real roots. There are solutions in the imaginary number system, just not in the real number system. So using the discriminant is useful because I can tell how many solutions there are without actually just solving the question. So let's just summarize this in a table. So if my discriminant is positive, this is a good chance for you guys to review this. You could pause the video and see if you're correct. So if the discriminant is positive, I'm adding and subtracting a number, so I have 2 real roots. Could you draw me an example of what the graph of a quadratic with 2 real roots would look like? Maybe something like this, where I have 2 x-intercepts. If the discriminant is negative, how many roots would I have? So in other words, if I am going to take, and this is what the discriminant is all about, it's what it is before I take the square root. So if the discriminant was negative, it's like I'm taking the square root of a negative, and I can't do that. So there's 0 real roots. So an example of a graph of a quadratic that has 0 real roots would be something like this, because it doesn't cross the x-axis. Now imagine my discriminant was 0. So imagine I'm taking the square root of 0. So if I take the square root of 0, adding and subtracting square root of 0 doesn't go anywhere. So I really have 1 real root. So if I have 1 real root, I have 1 x-intercept, it would be a perfect square trinomial. So something like that. Okay, what about if I give you the picture of a graph and I want you to match the conditions to it? So we've got different conditions for b squared minus 4ac, so hopefully you just recognize that as the discriminant. And then different conditions for a, which is our leading coefficient. And then different conditions for our lonely number c, which I hope you remember is your y-intercept. So which one of those match the graph? Well, let's see. First thing I notice is that the graph opens down like a frown. So I know that a is negative. In other words, it's less than 0. So less than 0, less than, so it's not this one or this one. So I can cross off C and D. C is the y-intercept. So I know if this continues going down, 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 my y-intercept could be somewhere there. And in that case, I know that my y-intercept would be negative. So A is negative and my y-intercept is negative. It looks like this might be the option. Let's just examine the discriminant. So because there are no x-intercepts, I know there are no real roots, which means my discriminant is less than 0. It's negative, and that satisfies this. So it looks like A is in fact the answer. Okay, let's use the discriminant to determine the nature of roots. So I want to determine, without actually solving it, how many solutions would this question have and what type of solution would they be? So let's look at the number in front of x squared. The number in front of x squared is 1. So if a is equal to 1, I'm going to put a 1 there and also here. Remember, my discriminant is just b squared minus 4ac without the root. Now b is the number in front of x, which is -6. And c is your y-intercept, or your lonely number, which is +9. So all I have to do is just evaluate this. I can just put it straight into the calculator. And I get a discriminant of 0. So square root of 0, that means I'm adding and subtracting the square root of 0, which is just 0. So if I add and subtract 0, that really means I have 1 real root, which means this is a perfect square trinomial. Okay, let's try a little twist here. It says, find the value or values of k so that y equals 2x squared plus kx plus 1 has 2 distinct solutions. Again, distinct just means different. Well, if I have 2 distinct solutions, I know that my discriminant has to be positive or greater than 0. Let's start substituting in my numbers. So my b value in front of x squared is 2. So that goes in or sorry, my A value, not my B value, my A value is 2, so it goes in those two places. My B value, the number in front of X, is K. So I'm just literally going to put K in there. And my C value is my Y-intercept, or my lonely number, which is 1. So let's tidy this up a little bit. I get my discriminant is equal to K times K, or K squared, minus 4 times 2 is 8 times 1 is also 8. So my discriminant is K squared minus 8. Now I want that to be positive. So I think back when I see this to chapter 3, and I think of the graph. This is a quadratic graph, a parabola, that has been moved down 8 units. So I know it opens up, it's been moved down 8 units, which means it has 2 x-intercepts. So I'm just going to go to my graphing calculator to get a good idea of that. And I know that my x-intercepts are positive and negative root 8. Now for my discriminant to be positive, there are 2 areas that is happening. One area, if I can write on the graph, there we are. One area is here to the right of root 8. The other area is here to the left of negative root 8. So I know if K is greater than root 8, or K is less than negative root 8, the quadratic will have 2 distinct solutions. Now we should simplify root 8 because there is a perfect square factor of 4. So square root of 4 is 2 root 2. So what I'm going to say is that my discriminant is greater than 0 when K is greater than 2 root 2, or K is less than negative 2 root 2. So anytime you have something where you're solving for part of the discriminant and you don't know your B value, so if you don't know your B value, always look to the graph. So this student is being a little cheeky with nature of the roots, handing in a blank test, and the teacher says, "Why are you turning in a blank sheet of paper?" And the student says, "Because all my answers are imaginary roots." Don't try this at school, it probably wouldn't fly, but I thought it was good for a joke. So you guys have questions 3 to 6 in the notes here, and then you can move on to the textbook solutions. I hope this video helped, and I look forward to seeing you for the next one.